Guess who's back? Jada's back. So today we're going to look at another trip that she made on her motorcycle. This time she's headed to school, but she forgot her AP Cal BC assignment to turn in. She must travel back home to get it. Does she ever make it? How can displacement and total distance help us investigate? So take a second and see if you can answer these 4 questions. Alright, Jada left her house at 7:30 a.m. and arrives at school at 8 a.m. The graph below records her velocity in meters per minute, where the time access is measured in minutes. Okay. Alright, so how far does Jada live from school? So what am I going to look for? So the total. So we'll go from 0 to 30. Alright, so from 0 to the 30. So it takes her 30 minutes, right, to arrive. So what is that going to be? It's going to be 10:50. Okay, how far did Jada travel on this 55-minute motorcycle ride? So the total distance that she traveled. So what am I looking for here? So the total distance, so I'm looking for how far she traveled. From 0 to, what, 60? But the absolute value of that. Oh, 55, I'm sorry. And why am I going to do the absolute value? Because I'm looking underneath the curve here. So what is that underneath the curve? So what is that? So that's what? So 1, 2.5. So that's what? Negative 500 under here. So we'll add those two values together. So it's going to be 1550. So how far from home is Jada at 8:25? So at 8:25. So this is going to be, what am I going to do? So how far away is she from home? So this is my displacement. So this is 1050 minus your 500. So this is, we'll subtract it. So how far away is she going to be? So that's going to be what? 550 meters. So this is displacement. And this is total distance. So what happened to Jada? Did she ever make it? Be creative. Alright, so did you think of something creative to do? To put it there for me to read. Okay, so this is net change. So net change is our integral from on a closed interval of then when we integrate and we subtract, this is our net change. Sorry, that's an f of a. So after you integrate and you evaluate, this is considered your net change. So when we look at an integral of velocity, So anytime we're looking at linear motion with velocity, the integral from a to b of that velocity function, this is called displacement. On that interval from a to b. The absolute value of the velocity function, that is total distance. So this will be total distance. All right, so take a minute and see if you can do these bottom questions, these check your understandings, and this calculator active for your response question. All right, looking at this one, a particle has velocity of t cubed minus 10t squared plus 24t in meters per second. Set up an integral to compute the following and give the correct units. So the displacement on 0 to 6, from 0 to 6, of that velocity function. So you can use Math 9 since it's calculator active here. And then your calculator should give you 36. And then this is in meters. The total distance traveled over that time frame from 0 to 6. So that means we'll put the absolute value function in there. And what do we get? Total distance, when you plug that in there, it's going to be 49.3 repeating. Okay, so Math 9, remember to set up these, and then to get that absolute value, I think it's under Math, and I'm not sure what number it is on right now, but I think it's like the third one down. So if y'all finish up this calculator active question and then submit your notes. I hope y'all have a great day.